Okay, previously we have discussed how to create a sheet metal base and how to create the various flanges. So in the next chapter, we are going to learn how to edit the flanges. The first edit tool is extend flange. It can be used to extend or shorten the flanges by different methods. Here you can see three methods: by value, through into, and to select it. The first one is extend the flange by typing its values, which can be positive or negative. And the second one and the third methods are quite the same, which is extend to a reference plane. But difference is to extend to fit the plane or just stop to contact the plane. Besides, you can set the extension methods. There are two methods available: normal to the extended edge and along boundary edge. You can easily tell the difference in below figures here. Besides, if you check the extend surface adjacent to the edge option, the boundary of the bending surface will also extend at the same time. Next tool is bend taper. It's used to make a taper to flanges, just to avoid the interference between adjacent flanges or just create more flanges gap. And you can taper one side or both sides. And also you can choose to make a linear taper or a tangent taper. Linear means when you unfold, it's linearly connected. And a tangent means it will tangentially connect it. And for more settings, I will show you soon in the software. The last edit tool is normal cut. It is used to cut material from sheet metal. But you may wonder, why wouldn't just use the extrude cut to make it? That's a good question. So let's see what's the difference between them. For extrude cut, it will simply cut the material along a fixed direction. That's good when the sheet metal shape is horizontal or perpendicular. But when it's inclined, there will be a problem after unfolding. Here you can see the hole is not perpendicular to the face, which will be a trouble in the laser cut process. So this is where we use the normal cut. It's different. Firstly, it will project the profile onto the shape. Then it will cut the material perpendicular to the faces, so that in the unfold result, it will always be perpendicular. Alright, now let's move over to ZW3D to check further about the edit tools. Alright, here we are. Next, I will show you the editing tools. And the first is the extend flange. And we select the edge. And here we have three methods. First one is extend by value. Easy to understand. We just drag it, or we can type the value manually. And the next is extend until. And here we can choose a reference. It can be datum or a planar face or sketch. Okay, here we can set offset to 0, and we select the datum plan. And here you can say it will extend to fit the target plan, right? And let's see the third one. It will extend to contact target plan. Maybe it's not so clear. We can make the datum bigger to see more clearly. Here we can customize the auto size. Okay, now you can see it very clear. It will only contact the datum reference, right? Okay. Okay, let's continue to see more options about this command. This time we still use the extend by value and select another edge. And here you can see we've got extension methods. for side 1 and side 2. And for side 1, we can set it normal to edge. And you can see the direction to the edge is 90 degrees. And also the other side, we also make it normal. Let's see the other option, along the boundary edge. It will extend along the linear direction of the boundary. And in this case, you can choose whether to extend the adjacent bending surface. Here we can check it to extend. Okay, now we can check OK. Now this is the final result. Next, I will show you how to use the bend taper command. We use another case. Okay, the purpose of the bend taper is to taper the flange to avoid interference between adjacent flanges or create more flange gaps. Okay, first we select bend. And here you can see we can choose to bend one side or both sides. This one is one side, only side 1. And side 2, only side 2. And we can choose symmetric. It will bend the taper symmetrical. And whether to opposite the direction. Okay, now let's see more definition, the taper definition. And we can choose to taper linearly or tangentially. Now let's see the linear. When we unfold it, you can see it will just linearly connect it. But if we choose tangent, now let's see again. You can see in the corner it will tangentially connect it. Okay, now let's see more options. And for the setback, we can define it by ourselves. For example, we can make it bigger. Okay. And also, if you use linear, you can set setback or the bend angle. Now we use the bend angle, you can see. Also, we can customize the value. Okay. And for the web, you can see if we select none, it will only taper the bend. You can see. And the other will not be tapered. But if we choose face, you can see it will taper the bend and the adjacent web. You can see, but not the other. And the last one is face chain. It will taper the select the bend and all the webs and the bends in the chain. You can see. And also we can use the different angle for the other bend and the webs. For example, we use 30 degree. Okay, it's too big. And we can make it smaller, like 10. And maybe it's still too big. We can change it to a smaller value, 3. Now it looks good. Okay. And this is how to use the bend taper command. And next, I will show you the normal cut command. We use this case. And here you can see for the vertical area, actually it's the same with the extrude cut command. But for the inclined area or the bend area, we must use the normal cut command. Otherwise, if we unfold it, you will see the whole face is not vertical. So it will not meet the requirement of the manufacturing process. Now let's see how to use it. First, we choose the profile and the cut shape. And here you can see, actually we have two methods. First one is normal to both sides. The profile is projected onto both side face, and then cut material on the thickness direction and merge it. The second one is normal to middle. It will project on the middle plane of the sheet metal part and then remove the material. Now we just use the second methods. And for start and end, we keep it by default. Okay, now let's see the result. Okay, and we can compare the result between normal cut and extrude cut. Okay, we can extrude. Okay, and here we can make the color of the shape different to see it more clearly. We use green. Okay. And now you can see actually in the inclined area, the result of the extrude cut and the normal cut is different. But in the vertical area, it's totally the same. Maybe we can make a section to see it more clearly. Section. Okay, we choose a line plane. Okay, now let's see. Now you can see in the bend area or inclined area is totally different. And we can go deeper and see in the vertical area it's completely the same. Okay, now you already know the difference, right? Okay, this is how to use the it's how to use the normal cut function. Thank you for watching.